Welcome students for the chemistry lecture. Here last time you have learned the simple eutectic system, that is the general case of simple eutectic system, and regarding the reduced phase rule. You know the Gibbs phase rule, F it is equal to C minus P plus 2 by keeping one variable constant. That means we put pressure constant in case of solid liquid equilibria, and the phase rule becomes F dash it is equal to C minus P plus 1, and this is the reduced phase rule. And to explain the two component system, we use this reduced phase rule. And again, the two component systems are also called as condensed systems. And again, you have learned, if the maximum 4 phases are there, then 4 minus 4, then there is a minimum degree of freedom. And if the two components they present in one phase, here the degree of freedom it becomes equal to 3, and means we need a 3 coordinate axis to explain the two component system. And every time on plain paper it is not easy to show 3-dimensional 3 coordinate axis here, and for a sake of simplicity we kept a pressure constant and we have a temperature composition diagrams in case of solid liquid equilibria. As the gas phase it has no effect on the pressure, has no effect on the gas, so we kept pressure constant. And here we today we see in detail the lead silver system or silver lead system, and the application of this lead silver system it is in the Pattinson's process of desilverization of lead. At first imagine, suppose we have solid lead and solid silver, and the melting point of lead it is 327 degree centigrade, and the melting point of silver it is above 12,000 degree centigrade. Imagine we have these two solids, and we take these two solids, pour these two solids in a big vessel, and we increase the temperature of these two solids above their melting points. We increase the temperature of these two solids above their melting points. That means we have heated above 1400 degrees centigrade. Then what happens? These two solids they will get melted, and we have a homogeneous molten mass or homogeneous liquid, and it is represented by the area which is above the curves A, B and C. A, C and B. As already you have studied the general simple eutectic system. Then when such a molten mass it is cooled, when such a molten mass it is cooled at the melting point of the lead, that means 327 degrees centigrade, we get a freezing of a lead. We get freezing at point A. That means the melting point of lead. And at the temperature of melting point of silver, we get solid silver. in the molten mass. And remember that the end of freezing, that means beginning of melting. So the A point and B point, they are also called as freezing points or melting points of the solids. Let us see in a detail the lead silver system. Here we have, this is the phase rule. F, it is equal to C minus P plus 2. And for two component system, we have F, it is equal to 3. That is, we need to mention three variables, and that three variables are temperature, pressure and composition. To represent them graphically on three axes are required, which cannot be represented on paper. Generally, for gas phase effect of pressure is negligible. That means discarding pressure, the equation changes to F dash, it is equal to C minus P plus 1. Instead of 2, we written here one variable constant. So our reduced phase rule or condensed phase rule, it becomes as F dash, it is equal to C minus P plus 1, and this is called the reduced phase rule equation. Remember well, by using this equation we can determine the degrees of freedom and number of phases, and we can explain the phase diagram of two component system. See here our detailed study of lead silver system. Here two components are silver and lead. The phase diagram for this system is, this is the phase diagram of lead silver system. Here, see here, at this x-axis we have 100% silver, or you may take here 100% Pb also, as you wish. Here they have taken the 100% silver and 0% lead, and at this axis we have 0% silver and 100% lead. See here, they have taken 100% lead and 0% silver. And as already I have explained you, 327, this is a B point, and it is the melting point of pure lead. Melting point of lead. And here 961 degrees centigrade, it is the melting point of pure silver. Melting point of pure silver. And as already you know, the melting point of silver, it decreases along the curve AO due to successive addition of lead into silver. Here the percentage of lead, it goes on increasing. It goes on increasing, and here the melting point of silver, it decreases along the curve AO, and along the curve BO, the melting point of pure lead, it goes on decreasing due to the successive addition of here silver into the pure lead, and the region which is above the points here A, O, B, we have liquid melt. That means we have heated silver and lead well above their melting points. And all of you know, to mention or to state any point in this region, we require two variables. Here, temperature as well as composition. That means the areas are bivariant system. Then, along this curve AO, two phases are in equilibrium. Along this curve, AO, two phases are in equilibrium. Here, silver solid and molten mass, that means liquid of lead and silver. Thus, the curve AO, it is a univariant system. Similarly, the curve here BO, along this curve BO, two phases are in equilibrium, solid PB and the molten mass or liquid. Thus, again, by the use of reduced phase rule, the curve BO is a univariant system. That means if we mention its temperature, automatically composition it will get fixed. Composition it will get fixed here. And this is the eutectic temperature having 303 degrees centigrade. At this low temperature, the in the molten mass solidification of Pb as well as Ag it takes place. At this point O, three phases are in equilibrium. Here solid Pb it is in equilibrium with solid Ag, and above this there is a molten mass. So this O point it is a triple point, and this temperature it is a very low or very less as compared to the melting points of Pb and Ag. Thus, this O point it is called as the simple eutectic or AZ melting point. And see this line DC. This is the solidus line. Below this temperature, we have only solid Ag here and here solid Pb here. This is the phase diagram of lead silver system. You may put Pb here or here, depending on that this diagram it changes. And see that at the eutectic point the percentage of silver here it is 2.4%. The 2.4% silver we have, and the 97.6% that of lead. Here we will see the cooling effect. Suppose we have the liquid composition represented by this O point, X point, sorry. We have, this is the liquid composition represented by this X point, and we going to cool this composition. Then what happens? This cooling of that composition it will takes place continuously up to this point, that is on the curve BO. As soon as we arrive at the point here in the molten mass, the solidification of Pb takes place. In the molten mass, freezing of the Pb takes place, and here by the method of filtration we remove Pb from this composition. Again on further cooling, here we reach here. Again here Pb is solidified or Pb get freezes, and we remove this Pb. Again on further cooling we reach at the point here O, and we completely remove the Pb here, and at this point we obtain the 2.4% silver and 97.6% Pb. Similar is the effect if we have any composition here and we want to cool. As soon as we arrive at this point, which is on the curve AO, here the silver it will get solidified, and we remove the silver. Okay. Similar is the any composition which is above this O point. Okay. And this phase diagram of lead silver system, it has the application in the Pattinson's process of desilverization of lead. Then, as already I have explained you, in the phase diagram, areas are bivariant, curves are univariant, and the triple points are invariant or non-variant. See, the curve AO and BO or OB, the point A represents melting point of silver, and it has a value 961 degrees centigrade, and point B, it is the melting point of lead, it has a value 327 degrees centigrade. When lead is added to silver, its melting point decreases, which is represented by curve AO. Similarly, when silver is added to lead, its melting point decreases, represented by curve BO. On these curves, two phases, that means metal and the melt, are in equilibrium, and any point on this curve is a monovariant. It is a monovariant. From the phase reduced phase rule, F dash, it is equal to C minus P plus, here plus 1, we get 2 minus 2 plus 1. That means here plus 2 minus 2 0, and we get F, it is equal to 1. That means these curves are univariant, and these curves are called as freezing point curves. Freezing point curves. Then the Eutectic point, O point. The O point where the two curves AO and BO meet is called Eutectic point. It is the lowest temperature, 303 degrees centigrade, at which liquid phase can exist. Here, three phases, solid, silver, solid lead, and melt, exist together in equilibrium and having the composition 2.4% silver and 97.6% Pb. It is an invariant system or non-variant system, and by the application of phase rule here, F dash, it is equal to C minus P plus 1. Here the value of C, it is equal to 2, P, it is equal to 3. Therefore F, it is equal to 2 minus 3 plus 1, it is equal to 0. That is, the Eutectic point are invariant or non-variant system. Then the areas. The areas above the curve AOB contain only liquid melt of silver and Bb. So, it is a bivariant system. The areas AOD and BOC, two phases, solid metal and liquid melt. So, it is a monovariant system. Then the areas below the curve COD have two phases, metal and Eutectic. Here the degree of freedom is 1. And this is the explanation of lead silver system. Then the application of the lead silver system in the desilverization of lead. Here lead sulfate, that is galena, an ore of lead, contains small percentage of silver, very less percentage of silver, and it is about 0.1%. This can be removed using the phase diagram. This ore is heated to form a liquid mixture of two metals represented by point X. Then it is allowed to cool till the point Y is reached. Here, lead starts crystallizing out, increasing the percentage of silver in the melt. This process continues till the point O is reached, where eutectic mixture of silver and lead are formed. This is the explanation of desilverization process. I hope you will understand, and if you have queries, then you may ask me. Thank you.